All right, so you can't see that anymore. Hello, girls. Okay, here we go.
Oh, I just made these the same. These are the same.
So as we do this, does anybody not have the programs that I shared over the past couple of days? While you guys are taking, I can't give them to you because of the TI9 at the office. We can for sure. Keep your hands up, guys. If you're taking notes, you have this, of course. You have this in the PowerPoint from Tuesday. You'll have it again today, linked. When I get back to the office to do it. Corbin, yeah.
Is that something I can just like pull off the internet?
Well, you can probably pull off variants of it. I can email mine to you if you have a cable that you can hook your TI into the computer.
Dude, I don't have it on.
No, if you don't have it on, you just send me an email. I'll send you my programs. And you can also pull them offline, whatever's easier for you. They won't look exactly like mine, but if you can live with it, that's totally fine. Okay, no problem. Who needs it? All right, can we share? These do make life easier.
You should download
And of course, there are also tools you can use online that are different than these. The only reason I'm doing this is so we have a tool in class to get numbers. Yes, I'm sure there are tons of apps available that are probably higher tech than mine, I would imagine. I believe that's okay.
Yeah.
Go. So, what makes a binomial a binomial? Here's the first. Sorry, you need it? Here's the first. Here's the first. There are a few important words up there. I've made this as little wordy as possible. The first thing you have to do is you have to have a fixed number. This is texting my ADD, but you guys don't even know. Talking and typing things on the computer. Uh-oh. See, I had to stop. Sorry. As I walk, I'll talk.
Yeah, I got one too.
We got one. Oh, I'm not talking yet. This guy here. This guy.
Yeah, he's programs.
Ryan in Jersey says for a baby. This guy. This guy knows a guy. Little guy. I'll show you what's going. Nobody knows yet. I just shared it last time, John. Didn't give it to anybody. I mean, just didn't give it the 411 there. Just there. All right, there you go. So, fixed number. First, you have to define how many trials you're going to run. When I sent Max into the chicken store, I said, go get 4, or actually go pick 4. They won't let you actually pick them up until you bring them home. We'll show you how to use them all. Who else needs them? We're golden. All right, sweet, honey. So, I didn't say, Max, go in. I didn't give him the box and say, go in and fill the box. You don't give that to a 6-year-old. Come back with a box full of dead chicks. No, you say, here's a box. Go pick 4 chicks, whatever 4 you want. So that's a fixed number of trials. Fixed number of trials. I didn't say, go pick chicks until you have 4 Orpingtons. Fixed number of trials. 4 birds. This is the one, this word right here, I want to emphasize in particular because technically speaking, they're not independent trials. Do you remember why? We had a big discussion about this on Tuesday. Remember why Max picking the chicks up, putting them in the box, and then bringing them home? Technically, they're not independent. Technically, do you remember what the logic was, why they weren't technically independent? Richie, how come?
Because each time you take one out, you have one less.
Because when you take the chick out of the pot of birds that are in there, you're now changing the percentage of those that remain. Now, why could we arguably say they are independent in that case? We're only changing it this teeny tiny amount. There are so many birds, and he's only drawing 4. If there were 5 birds in the bin and he pulled 4 out, I wouldn't be talking about this, because it's not this at that point. It's not this. One of your problems in the project is also not this. The project with the blocks in the bag, you have 10 blocks, you're pulling 4 out. You can't use the binomial on that, because every time you pull out a block, you're removing at least 10% of the remainder. That's far too much. That would be like going into the store with 500 birds and saying, Max, go buy 100 of them. Go pick 100 of them. Okay. First of all, he'd enjoy that. But secondly, this math falls apart. Because well, the first couple won't change the percentages at all. But by the time you're done, you will have removed 20% of the population. That's not binomial anymore. Is that fair? What's a really good question that follows that then, of course? If drawing 100 out of the 500 was too many, but drawing 4 out of the 500 was not too many,
Wouldn't it be what's the right number that's not close enough?
Caitlin,
to
thank
fit
you.
the other space?
Yes!
5%?
What's the right number? And that is a good guideline to use. As long as you can convince yourself you're drawing no more than 5% of your population. FYI, this is an outside of class comment. This is when you go out and do your own research and you're doing your own research more than I'm going to test you on that. Keep that in the back of your mind. As long as you can convince yourself you're drawing no more than 5% of your population, then we're good to go. Is that fair? Is it maybe fair?
Yeah.
It's a guideline. If you want more data, I've got simulations that can show you why 5% usually works out pretty well. And it does, especially for really, really large sample sizes. The good news is, nobody even gets close to that. If you're sampling, for example, American voters to find out what their approval rate of Congress is, FYI, it's really low. Generally, Gallup will ask like 3,000 or something like that. Well, how many voting age Americans are there? Like 200 million, right? So they're only getting like 0.0001% of the population. So as long as you're not drawing hundreds and hundreds of thousands of people, you're not getting anywhere near. Even if you were, you're not getting anywhere near the population. Does that make sense? And Caitlin, thank you. That is an awesome question to ask. At what point does it become too big? Keep that 5%. The 5% is such a common number in statistics. Let's just keep it handy. That's a good place for it. Fair enough? Other questions you got right now? Cool. Why is it called binomial? Because there's two possibilities of what can happen. He reaches his hand and grabs a chick. Male or female. Now, I did have that student last year, year before maybe, that said there's a third outcome. And I've got the distribution. I made it up. I made it up yesterday. I'm going to make a quiz for you guys for week 10, if you want to do it. You can figure out, I'm going to give the distribution for the trinomial situation. You can find the average of that, and see if it was worth talking about. That's the point of my emailing back and forth with the student. I wish she had actually emailed me back. I sent her all this beautiful analysis back, and I never heard from her again. That happens. So promise me, if you ever pull that crap, you'll keep emailing back and forth until we both have a happy resolution. Thank you. In other words, you're responsible for the last email. Okay, there we go. N plus 1, N. Yes, that's the way it works. Okay, so 2 mutually exclusive outcomes. Boy, girl, male, female. What does mutually exclusive mean again? Remember what this is from your first project. I'm being a bastard here asking this question.
I think it has to be one or the other.
Boom! It cannot be both. Thank you, Carolyn. Perfect. It has to be one or the other. Another word we used, I think, was disjoint. I think there was another word that sometimes used, disjoint. And again, this is also, you can see why this is broken by that student's definition of a 1 in 10,000. Because it can be both 1 in 10,000 times. But we're going to ignore that for the time. You'll see why in the quiz for next week. Don't worry about that, Sarah. It was that one goofy situation. Just let that wash over you for right now. If you want to do the quiz next week, 2 weeks, you can look at that and be like, oh, I still don't care. That's totally fine. And because of both of these things together, I like talking about this third little issue, which is, since we can't be both, but we have to be one or the other, Carolyn said that perfectly, the probabilities of the 2 outcomes have to add up to 100%. Out of the way. You have to be one of them. You have to, I apologize. For some reason I put it in the middle of it, I don't know why. You have to be one or the other. So whatever the one probability is, the other one has to be the complement of that, because they have to sum to 100%. There's no overlap. And that's because of the independent bit. The fact that there's 2 that add to 100 is why there's the 0.9 and 0.1. There's only 2, there are only 2 numbers there. That's it. If you can say yes, 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 then you've got yourself a binomial distribution. You've got yourself a binomial distribution. If you say no to any of those, you're not SOL. You just have to use a different distribution. Every data set I have played with you guys with in this class belongs to a class of distributions. I was going to show it to you today. There's a beautiful piece of artwork that I found that has all the distributions listed out on it and arrows leading to each one. It's like a family tree of distributions. Oh, I want to frame it. You guys don't see it right now. It's okay. We're saving for next week when you're fully charged. So at the end of the week, you guys kind of get this like low ebb charge. Every situation you're going to encounter in your life statistically falls on that chart. But this one is probably one of the most central ones on that chart as far as occurrence in your lives. Knowing that you guys are soc majors, psych majors, HDFS majors, exercise science majors, business majors, and I named a few, nursing majors. I know I missed a couple of you guys, and I apologize if I missed anybody else, but all of those, you guys consume research over and over again. And so much of that research, especially in the psych fields, the social fields, is on qualitative data. And that qualitative data falls directly back into this distribution. And you'll see how in Math 244, should you take that 244. And even if you don't, you're going to see it, whether you like it or not, it's going to be there. So this is one of the more important ones. So grab your TIs, let's construct the distribution that we did in class yesterday. Remember, actually, look, we can construct a whole bunch of them if you want to. We can do all 4 of them in a row. 1 flock, 1 bird. Second flock, 2 birds. Third flock, 3 birds. And finally, my flock, 4 birds. We can actually do all 4 of them just for practice. So I gave you all these beautiful programs. Let's show you how they work now. Let's move the camera around a little bit. Get that right there. Can I put this in the middle now if we do the T? Okay, that way everybody can kind of see it equally, okayly. Zoom in. Not too big.